As you know, in the last video, lesson 11, we learned about switches in BASIC. So this is lesson lecture 12, switch operations in more detail for the CCNT ICND1 or the ICND 100-105, the most current exam. I'm going to teach you guys what you need to know. So, without further ado, let's get to it a little bit. So I've been busy. Sorry for the last few videos. It's been a little bit later. I've been actually tutoring a lot for networking students, and it's going really well so far. And I'll give you guys the information at the end of the video for anybody who's interested. So what we're going to be talking about today, guys, is ARP on a switch. That's where we're going to start. So let's start with ARP. So what I'm going to do is first we're going to take a look at the definition of ARP. So ARP is short for Address Resolution Protocol. Address Resolution Protocol is a protocol for mapping an Internet Protocol address, short for IP address, to a physical machine address, which is known as the MAC address, that is recognized in a local area or a local network. For example, in IP version 4, the most common level of IP used today, an address is 32 bits long. In an Ethernet local area network, however, addresses for attached devices are 48 bits long, meaning that your layer 2 switches works off of MAC addresses. A table is usually called the ARP cache, is used to maintain the correlation between MAC addresses and corresponding IP addresses. ARP provides the protocol rules for making this correlation and providing address conversion in both directions. So, for ARP, it would be basically saying that from here we got an address of 10.1.1. The other PC has one different. So we're going to do a ARP/A. Notice we have no ARP entries. So let's ping the PC across in this topology, which I have set the address statically to 10.1.1.2. Oh, sorry, I need ping in front of there. Notice that we ping, and when we ping, we also build an ARP table, and notice the physical address, which is also the MAC address, and then we have an internet address table. And notice that now the PC knows that this IP address has this MAC address, and vice versa. This MAC address has this IP address. So it builds a table to basically know what devices or end user device has for an IP address / MAC address. Now, one is built upon devices also. But on a PC, if you want to check yours, you can always do a ARP-A in the command line or command prompt, and you will see your ARP table all. So next, ARP is pretty simple. It resolves the MAC address to the IP address, and you could also say that it resolves the IP address to the MAC address, but in most cases it is a physical address being resolved to an IP address. But how is ARP even possible? How does it figure it out? How does it get to it? It uses something called broadcast on the physical address. So we're going to look at it. So switches work on MAC addresses unless you're a layer 3 switch. So switch bases on how it switches on the MAC addresses of end user devices. So we built this table, or built this topology, and what I want to show you guys is that right now this topology, if I do enable show MAC address table, notice I've got several entries in here. So what I'm going to do is we're going to start it fresh. So let's power cycle the devices. I'm going to click yes. It's going to take them a little while to converge. I need all green. So how a broadcast works, you have two versions of a broadcast. And in this video, we're only going to talk about the MAC address. This is a broadcast MAC address. I was trying to juice this font up some. There we go. So this right here, FF is a broadcast MAC address. So to explain that before we actually put it into play, what a broadcast MAC address does in written terms is it broadcasts to find out where a device is usually, and the way that it finds it before it builds any kind of table is that, for example, let's say PC1 is looking for PC0 is looking for PC1. It will send out a broadcast out of this port, and it will ask switch 4, do you know where PC1 is? And switch 4 will not know. So basically, here's usually what happens. Let's say I send a ping. Let's go back to the start, because this is going to probably be the best method when I think about it. So PC0 wants to ping PC1, but none of these guys knows where any device is. They just come on. They won't have a MAC address table. They might have a little bit, and I'll show you guys here shortly. So PC0 wants to get to PC1, but it doesn't know how, and neither does the switches. So how did they work? They use broadcast. So PC0 will send over here to the switches and say, hey, where is PC1? And then get to switch 4, or the first switch that it rides to. It's going to look at its MAC address table. If it does not find the entry, it's going to send out a broadcast frame asking the same question, where is PC1? But the broadcast will come in from PC0's connection to the switch. The switch will flood all ports except for the port that it received it on. So basically, it will go through these two ports, but not this port because it received the traffic on it. So it will broadcast across both of these, and switch 4 will ask, where is PC1? To switch 5 and switch 7. Switch 7 will not know where PC1 is. It will send out a broadcast out of all ports, except for the port that it originated or came from. So it will dead end on the PC7, and it will drop the frame because there's no more connections. Or switch 7, sorry. But switch 5 will broadcast out of all ports because it doesn't know where PC1 is. It's going to ask. It doesn't see it in its MAC address table. It'll look in the MAC address table first, and then if it does not have it in the table, it will broadcast. Remember, it will send a broadcast out of all ports except the port that it received it on, which is switch 4's port down here. It will not go back out this port. Instead, it will go through this port. Now, if it had more, it would go through multiple ports as it did down here at port 4 or switch 4, but it did not. So to go to switch 6, switch 6 will look at its MAC address table, and if it isn't in there, it's going to send out a broadcast also, except for the port that it came on. So it will not go out that port, it will go out this port, the PC1. And PC1 is going to say, hey, that is me. And it will go. Now, if we have other PCs out here, they're just going to drop the frame when it floods. But PC1 will be replying. It's going to say, hey, I'm PC1. I'm who you're looking for. And it's going to go to switch 6, which now knows the path because of the broadcast and how switches work. Now it knows the path to PC0. So switch 6 will say, hey, PC0 came from this port. Let's go out there. Its MAC address came from here. Switch 5 is going to say, hey, PC0, yeah, I know where that is. That was on the port going to switch 4. I'm going to send it through that port. Now here's where you've got to really pay attention. So switch 4 has a MAC address table and knows where PC0 is. So it's going to send it out the port that PC0 is. It will not come back out this port. Now it knows where it is, so it's not a broadcast frame once it has it in the MAC address. It looks in the MAC address. If it has it, it knows. So switch 5 has PC0 in its MAC address table. It pulls the MAC address from the packet, which we will learn a bit more later on. So let's put this theory into testing. So let's take a look here. We're going to look at the MAC address over here on switch 7. Show MAC address table. Notice I've only got the MAC address to switch 4. Now if I look at switch 4's MAC address, it might have 3 in there, because over time it's going to learn. Alright, it does not know about the PC yet, so switch 4 has not learned where the PC is. And switch 6 had not learned where PC 1 is. So okay, let's do that in real time. Now if we remember, when I ping, we reset the devices, so when I ping, notice there's no ARP now. So when I ping, because we reset, so if you reset a device, you lose your MAC address table, you lose your ARP cache. So we're going to ping 1.1.1.2, which is this PC up here. We're going to send out that ping. Notice it happens very quickly. So remember what we talked about here. It will broadcast to here and here because it doesn't know where it is at this point. This is actually happening. That's how quick it happens. And to be honest, a reply actually comes back. It says, hey, I'm PC1, except it goes this path by the reply. So switch 7, does it learn about PC0 and PC1, or does it learn about just PC0, or does it learn about just PC1? Think about that and answer. I'll give you 5 seconds. 1, 2, 3, 4, 5. Alright, so let's take a look. Notice our MAC address table has changed. We've got an extra entry. Remember, this is the switch 4. Switches send CDP neighbors, so they learn and they reply to each other, so that's how they pick up each other's MAC addresses, and you will learn about the CDP neighbor command in another video related to the switches, and it works with routers, so it'll be in probably the combined video. So the MAC address of P0 over here is 7,000, and switch 7 has the MAC address for 7,000. But notice, this is PC0. Let's pull up PC1, and then let's pull back up switch 7 side by side. We do not have a 088A in our MAC address table. Once again, it's not there. So what if I ping from PC1 to PC0? Do you think it then gets on the MAC address table? Think about that while I ping. Ping 10.1.1.1, because that's the address to there. We're getting replies. Basically what happens in a ping, it goes here, gets to the PC replies, and the ping becomes successful. So on switch 7, did it learn about PC1? What do you guys think? No, it did not. Once again, it did not. So why did it not learn about PC1? If you go back to what I originally talked about, remember that now the switches know where PC0 came from on which port based on its MAC address. So when PC1 sends out where's PC0, switch 6 is going to say, hey, it came from this port whenever earlier, we got it in the MAC address table. So it's going to go to this port. Switch 5 is going to look at its MAC address table and say, yes, I've seen PC0. It was off of this port, and it's going to send it only to that port. When it gets to switch 4, it's going to say, hey, I seen PC0 off of this port, and it's going to go here. So it never goes to switch 7. Now, why did PC0, once again, back to the start, and if you rewind the video, you'll hear me say this exactly. PC0, why is it in the switch 7? The first ping that we did, it went to switch 4, and remember, it broadcasted because it did not know where PC1 was. So to prove this theory, what we're going to do, I'm going to power cycle the devices one more time, and I'm going to do that in a opposite order, with PC1 pinging first, and then PC0 pinging second, and show you that in the MAC address table, it will pick up PC1 because of broadcasts, but it will not pick up PC0 because now the switches learn about PC1's location and which port to forward the traffic through based on the MAC address. And this is a very basic function, and you will need to know how this works. And remember, this is a switching technology. Now, originally there was hubs. We're going to talk about that in another video. Hubs aren't used anymore. So I like to talk about the older devices afterwards. Some people will talk about them before. I like to talk about the technologies and how they differ first, about what's being used, and then we will mention the old technology and why it advanced past it, which is hubs. So in a video 1 or 2 from now, you will see a video based on hubs, which is older technology, but you will need to know how they work, because in the ICND1 they expect you to know the difference between a hub and a switch and how it works based on collision domains. So okay, we got everything up and running. So let's go over here to command prompt, and notice we're going to come over here. I'm going to go to switch 7, show MAC address table. Notice we only got the MAC address of the switch. So let's ping from PC1. We're going to ping PC0. Let's look at the MAC address table. Notice now the MAC address table picks up PC1. Remember earlier it did not. Now when I ping back from PC0 to PC1, do you think that it's going to go in the MAC address table? And hopefully by now you know the answer to that, which will be no. Because now PC0 knows the path. So PC1, it was flooding through every port except the port that it came on. And then down here, let's look. Notice it did not make the MAC address table. So guys, that is how ARP works in a more detailed information. Your next video, all these videos will be a series of videos, so I probably should actually change the title, as you need to know how each thing works into somewhat detail. And I hope this video has actually been beneficial. I hope it helps you understand, and I hope you guys learn more. See you guys in the next video. Thank you for watching, and if you enjoyed and found it helpful, please subscribe. See you guys in the next video. Peace.